So the first thing that I want to talk about is the secure and communication channel. So most developers, when you ask them, well, what does the world look like? This is what comes to mind as a first thought. Maybe I have, the standard three-tier CRUD application that we see in the enterprise. You have some web browser or mobile app. It hits some sort of APIs, which then stores stuff in a SQL database. Like, how do you secure the communication channels here? What are the channels that you see? Pretty much everybody says, aha, obviously I should use transport layer security between the web browser and the mobile app to the monolithic backend. Okay, that's reasonable. And then when you talk to ops teams and you see like the classic way of doing this, people will kind of put it something like this. They'll say, oh, we're going to have these firewalls, and these firewalls are going to protect us. So we're going to have, my app, it's going to go talk to the load balancer, which is really going to talk to the application server, which is then going to talk to the database. And we're going to have a red network zone, a yellow network zone, and a green network zone. And so in our red network zone, we're very paranoid, and we're only going to be very precise about what traffic comes in from where. And then, and then we have the yellow zone, which has the app servers, and it's kind of our medium level of security. We want it to be secure, but it has to talk to the load balancer. And the idea here is that we'll have a firewall to say only the load balancer can talk to the app server, and then from the app server, same sort of story to the database. The idea is the green zone is the most protected zone. You shouldn't be able to get from the internet to the database, and on and on and on. And this has been the model for many years, except that it kind of doesn't work because it doesn't protect you from many things that have turned out to be true in real life. Like, for example, you might have a disgruntled employee who is able to see the clear text traffic that might be going between the application server and the database and steal some data. You might have a misbehaving application on the network. Because these things are big. They're not like micro segmented for the most part in the enterprise right now. They tend to be like, oh, I have some other application in the yellow zone, and all of a sudden that application can maybe see stuff that's happening on this database because it did a bunch of illegal stuff it wasn't supposed to. So we don't want to do that. We actually want TLS everywhere. We want something called zero trust. So as a developer, it's really important for you to get not just comfortable with TLS. I want you to be able to prove as a developer all the naysayers that say developers should never configure TLS. I wanted you to prove them wrong. We're kind of in this situation in the industry where we're saying TLS is so hard to configure that mere mortals can't do it. At the same time, we haven't really put much effort in the industry at making TLS be easier to configure or educating developers on TLS. I hope my book plays a part in educating people on TLS, so TLS isn't so scary to configure and isn't so hard to configure. So that will improve security. Now, if we come up with, service mesh fixes everything, I don't know, maybe not. We still will have situations where we need to do that. In order to understand TLS and to drive it properly, this is where things get interesting. What do you need to know? Well, you need to know some cryptography. Otherwise, the TLS settings don't make any sense. So you need to know some concept called cryptographic hash functions. You need to know about something called message authentication codes, a variant of it called hash message authentication code. You need to also know about the advanced encryption standard, AES, these things called block encryption operating modes, something called authenticated encryption. And then you'll see people talk about RSA and elliptic curves and Diffie-Hellman and all these, what does this all this stuff means? That's what you should know about as a developer. Now, here's the really cool part. If you know this stuff, wow, you've learned the foundations of cryptography in a way that's understandable to you as a developer. It's going to make your life easier with anything involving security. There'll be lots of applications where knowing this will help you understand some other technology that you're using. So for example, you start deploying stuff on containers, on Kubernetes, and you're worried about the security of the software supply chain, and you start looking at things in the industry like SigStore, and you're like, okay, so we're going to have digitally signed container images, or I'm going to have a digitally signed jar file, or I'm going to have whatever it is. You need to understand these concepts in order to in order to like drive these tools and be able to understand them. I don't want any developer looking at these tools to find them hard. I want them to find those tools obvious. And if you know the cryptography foundations, those tools will become obvious to you. Now, the other kind of big part, and I wish I had pages in the book to cover this more, but it's kind of like the supply chain problem. I'm gonna, I guess, zoom in a little bit so you can see it. So here is a dependency diagram that shows on the right-hand side, let's say you include in your application a common dependency like Spring Boot starter data JPA. Well, when you include that, that will pull in Hibernate Core, which will pull in the JAXB runtime, which will pull in the TXW2 jar file, and the iStack Commons runtime. Now, I have no clue what TXW2 does or what iStack Commons runtime is. I have an idea what JAXB is, but it's like, all right, what if there is a security issue in TXW2? Like, as a developer, how am I supposed to know that I should include this or not on my? What if somebody hacks it? What if somebody, like the idea of a supply chain attack is somebody goes and replaces TXW2 with a some hacked variant of it, and these types of supply chain attacks are happening all the time now. Like, they are the most devastating types of attacks. I think the most famous one was against, I forget, was it called SolarWinds was the name of the attack, and it was against a network management software that was widely deployed in government and industry, and wow, like that got people really aware of it. For us Java developers, it was Log4j, right? I'm sure many of you may have spent a few days in the past few weeks going through your old applications and saying, okay, do I have this version of Log4j? Okay, let me upgrade that to the newer version. So we need a much better way of managing supply chain. And the supply chain, for it to be secured, is going to depend on all those cryptography fundamentals. So as those technologies come online for supply chain security, you'll be well positioned as a developer, if you've read this book, to kind of like take advantage of that. If I kind of was to kind of summarize what you should know or not know as a developer, I kind of look at it as a continuum, right? And on the left-hand side, you have a mathematician, and the mathematician isn't out there trying to, like, invent cryptography. They're just like solving cool math problems. And on the right-hand side is a hacker who's trying to get into your system, steal your data, and damage your company. You got the mathematicians, and you have the cryptographers, which are kind of applied mathematicians that take all of these mathematical properties of things, and they from that design algorithms for how to do encryption and various other things. And then you have security engineer standards, right? Because all these computer systems need to interoperate. So we need to have a way of agreeing on what algorithm we're using and how the algorithm is configured. So the security standard engineers are like the people who invent things like the AES standard or the SHA hash codes, or the elliptic curve cryptography, or the RSA cryptography, or OpenID Connect, or SPIFFE, or any type of these things. Now, once you have standards, well, somebody's got to implement those, right? So, for example, if you look at OpenID Connect, if you want to be the client library of that, that would be like Joe Granja on the Spring Security team. He implemented the client libraries for OpenID Connect for Spring users, right? So he's kind of like there, and he's also here in the framework engineer section. Or somebody implements the JOT standards. Now, once you have that, then you have the corporate kind of information security team, and the corporate information security team's job is to kind of basically look at all the standards out there, look at the regulations that the corporation must operate under. Maybe it's a bank is very different than a retailer, is very different than a factory, right, or a power plant. So based on that, the InfoSec team is going to say, in our company, for the type of applications we build, these are the requirements that we must meet. Sometimes the requirements are more stringent than minimum recommendations. Sometimes they are just the minimum recommendations, right? Now, you as the application developer are kind of stuck over here. You're expected to meet the corporate security standards And you're expected to be able to justify to any kind of security auditors or assessors why and how your applications meet security requirements. And presumably, if you follow the corporate info security standards and your application passes the audits and the assessors, it will be very difficult for hackers to hack your application.